So the 1.1 at the end is if you need the 10% of your propane for two reasons. One, so you get complete combustion, and second, so you're efficiently using your fuel. If you don't get all the energy out of propane, you're wasting your money. So, you want the oxygen to be in excess. Okay, so you said, what if you have, how much? I don't know, what did you say?
10 grams.
You have 10 grams of propane?
Yeah.
Okay. And what was your question again?
I was going to say, when you figure out the moles,
Yes.
you multiply it by the mole ratio, but how do you know, like, the exact, like, which one's, like, the one top and bottom?
Oh, okay. So what do I have 10 grams of?
Or propane?
Propane. Start using your chemical compounds as part of your units. And then it'll become more evident to you. So what is this balanced chemical equation, Devin? Good job. Okay, so here we go. So to figure out how much oxygen you need, you're going to have to do a calculation, convert it to oxygen first. So, you're going to put your mole ratio, oxygen on top, propane on the bottom so that propane cancels. Oh, I can't do that yet, can I? Why can't I do that? Why is this wrong? Don't copy it, Matt. It's wrong. What have I done? Big mistake. Identify the mistake that I just made. What do you have to have? You got to go from grams to moles. So, not good. So 10 grams of propane. What is the molar mass of propane? 36 and 8 is 44, right? 44 per 1 mole. Oh, did you wanted formulas?
That's fine.
Okay. So you would divide by this number, right? And you would end up grams over moles. So that gives you what number? I'll go from here, formulas. So what'd you get?
0.2267, 0.5962,
2267.
0.59.
Okay. So this is moles of propane. So this is the number you're going to multiply by the mole ratio. So you take that number and you multiply. Now propane is your answer, so propane has to be on the bottom. So it's going to be moles of C3H8 and then moles of O2, and it's a 5-to-1 ratio. So you need 5 times as many moles. So that gives you some number of moles of O2. And it doesn't matter if you multiply here by 1.1 or if you multiply your mass by 1.1. If you want 10% excess, okay? Are you okay with moving forward?
Yep.
Okay. I'm okay? So 10% excess. Normally, it's just a good number to have, 10% extra. especially if you're doing a combustion. You want to have at least 10% extra oxygen. So right now, all we've done is we've got a balanced chemical equation, collected our data, now find the moles of each reactant. I gave them to you. Okay, so once we have the moles, you're going to guess which one is limiting. So which one do we want to guess? Do we want to guess that aluminum's limiting or copper 2 chloride? And it doesn't matter if you're right or wrong because you will end up making the correct deduction. Aluminum? Okay, so if we assume, don't write anything yet. Just watch. So we're going to assume aluminum is limiting. Therefore, what you would have to do is figure out how much copper 2 chloride you would need. Right? You'd have to figure out how much you would have to use up of copper 2 chloride. So you would take the moles of aluminum and you would figure out how much copper 2 chloride you need by using the mole ratio. So somebody with a calculator. Okay, you're wrecking this for me.
That's my level
Yeah, but is this number correct? 0.013899. Okay, so it's not pretty. Okay, how do I compare it? If I need this much, do I have that amount? No. So therefore, I don't have enough copper 2 chloride to use up all of my aluminum. Therefore, I'm wrong. My copper 2 chloride is limiting.
So would you have to show that it is?
No, you don't have to do another calculation. Because you don't have enough, you're wrong, the other reactant was limiting. If you were correct, then this number would be smaller than this number. And you would have extra copper 2 chloride left over. So you only have to do the calculation once, you just have to have a statement.
Okay.
So you compare. So, need more CuCl2, therefore CuCl2 is the limiting reagent. Okay? We know the copper 2 chloride is limiting, therefore it limits how much product we can make. So, if we have 0.0037932 moles of copper 2 chloride, use your mole ratio from your balanced chemical equation to figure out how much copper you can make in terms of moles. So the ratio is 3 to 3. Just get rid of that. So, that's the exact same thing as 1. So we have 0.003793 moles of copper. We happen to know the molar mass of copper. Now you can find the grams of copper theoretically that can be produced if nothing else goes wrong. And you know stuff can go wrong in your experiment. Okay?
I have a question.
Yeah.
See the second line, you put 0.0.
So we found the moles of each reactant, multiplied it by the mole ratio of our product to our reactant to figure out moles of product that we can make. So what masses do you get? What masses do you get for copper?
Doctor, there will be a
With the smallest mass comes from your limiting reagent. So that means CuCl2 was our limiting reagent. And our theoretical yield is 0.24 grams. So it's like they're reacting independently, but the one that has the smallest amount of product made will be the one that gets used up if they were reacting together at the same time. So in this case, we're figuring out theoretical first, and then identifying our limiting reagent.
So basically it's just doing the first one, but doing the second one?
Yeah. And it's basically working backwards. So there's a whole 3 minutes left.